All right, now we move on to the inclined plane problems. So again, in forces, we have three types of problem that we solve. We have the elevator problem, which we just did in the previous set of videos. We have the inclined plane problems, which we're going to solve here, and then we're going to do forces and angles in general. So the key to the inclined plane problem is we start off with just our normal free body diagram. By the way, to get the direction of the reaction force, look at the inclined plane, and then perpendicular to it, you draw the reaction force like that. So that's how we got R. And the weight always points straight down. So those are the two basic forces that we've labeled here. However, the other thing we want to be clear on is that Fg actually has two components to it that we're going to draw. So they go like this, parallel and perpendicular to the inclined plane. Fg sine theta is one component that makes us slide. That's how we memorize where it goes. And then we have Fg times the cosine of theta, which cancels the contact force. And that makes it, and that actually cancels with R, that they should be in exactly the same plane as R. There should be an absolutely perfect ruler straight line. You should be on the same axis, just to be clear. And if you have a friction force, it should be along the same line as Fg. In this video, I want to do just a small proof, which is to explain where we get the sine and the cosine component from. So here's an inclined plane. And here's a box. And let's just draw the weight component right here, pointing straight down, and this angle's theta. Now here's the idea. The weight consists, and I'm going to call this, so this is W, and I'm going to just drop the two vector components down like this that make up W. So to be clear, this angle here is theta. That makes this a right angle, and this makes this angle right here equal to 90 minus theta. This is another right angle, and so this angle here is theta. So check this out. This length here, we call that the opposite. This arrow, W, is the hypotenuse, and this arrow here is the adjacent. So notice, opposite over hypotenuse is the sine of theta by SOHCAHTOA. So the opposite is h times the sine of theta, but h is just the weight. So that's how this arrow here is W sine theta. Similarly, adjacent over hypotenuse is cosine of theta. So that gives us A is h cos theta, but h, the hypotenuse, is just the weight. So that makes this component here equal to W cosine theta. So that's a quick proof of how we get these two components here. This is not something you actually need to know for the IB. It's something that you need to know how to label from memory.